Hi, I'm Michael, a PhD student in computer science at the University of California, Santa Barbara, and this is my FACT 2023 work, Disparities in Text-to-Image Model Concept Possession Across Languages. Of late, text-to-image models have grown increasingly popular, but there are three big socio-technical and scientific issues underlying them that this work is intended to address. Issue number one is, we don't really understand how they're so quote-unquote creative. The way that these T2I models have been sold to the public has largely been on the back of their supposed creative capabilities. And this has really been demonstrated by lots of really exciting demos, like, for example, OpenAI's DALL-E 2. The way that these demos typically go is that the purveyors of these models will show that they can creatively combine some set of known concepts into novel images, where they work in ideas and styles all together just from purely plain text. And we don't really understand the underlying mechanism that allows them to, for example, recover the concept of horse and combine it with astronaut in a coherent manner. The second and more fundamental issue underlying this is we don't even have a way to perform any kind of accounting on what kind of knowledge they actually have. So it seems plausible that in order to, for example, generate a picture of a dog made of fire standing on the moon, the model needs to know what a dog is and what fire is. But the nature of this requisite knowledge is not really well understood, and we don't have tools to test for it or to augment it if it's missing from some model. Finally, the third issue is these models often fail in problematic and unpredictable ways. So if you are the purveyor of one of these models, you really don't want it to be making offensive conceptual collisions. For example, in this case, when we prompt the model with, give me a picture of a big dog, in English, Spanish, and Indonesian, it succeeds. But if we prompt it with the same semantics, but in Japanese, it fails offensively, generating pictures of women rather than pictures of dogs in a field. This is unpredictable and a big issue if you want to scale these models up and ensure that they're appropriate for public deployment. So we make progress on resolving all three of these issues by studying text-to-image models through the lens of multilingual conceptual coverage. Some may wonder, why do we take a multilingual approach? After all, many of these models are trained and released with English-only use in mind. Well, first of all, multilingual capabilities just tend to exist, and this follows from the massive web-scale, incomprehensible nature of the training data that they're trained on. And we believe that it's important to ensure that these models actually work well on all languages for which they have capabilities. And additionally, looking at them through a multilingual lens allows us to do natural A/B tests that allow us to enable a deeper scientific understanding of how these T2I models work, hopefully. So to do this, we introduce a novel benchmark, which uses a multilingual concept list and some new metrics to compare behavior across languages. So now I will get into the details of that technique. The first thing that we need for our method to work is a good, aligned, multilingual tangible concept list. To do this, we start from around 1,000 common English nouns, and we use an ensemble of commercial translation systems to translate each into Spanish, German, Chinese, Japanese, Hebrew, and Indonesian. We then check the quality of these translations by both ensembling those multiple translators together and looking for agreement, and also for comparing them to BabelNet, which is an open source knowledge graph that allows us to check that indeed all the translations align with edges in the Wiktionary graph and are all tangible nouns. From that list of tangible nouns, we can then sample a specific concept and test a specific model by treating it as a black box. For each language, we can slot in a given word into a predetermined plot template. For example, in English, the plot template is a photograph of blank. So let's say we want to look at airplane. We can slot in airplane and say a photograph of an airplane, or for Spanish, un foto de avión, or for Japanese, hikoki no shashin, and then test each of those on a given model, which we treat as a black box. So for example, we run all those prompts on Stable Diffusion and then get at the output populations of images for each of those languages for that given concept. We then extract some features. In this case, we use clip embeddings, and then compare the populations of those embeddings for each of those language concept pairs in various ways to extract distinctiveness, coverage, and self-consistency features. The details are given more in the paper. We use our multilingual benchmark to assess the performance of a variety of commercial and open source text-to-image models, including DALL-E Mini and Mega, which are the basis of Crayon.com, Stable Diffusion 1.1 through 2.0, CogView 2, which is a Chinese language academic model, DALL-E 2 from OpenAI, and Alt Diffusion, which is a multilingual fork of Stable Diffusion 1.4. And now, on to the results. So what these plots are showing here are histograms for the conceptual possession, or otherwise correctness score, for each language model pair, for each concept in the histogram. Within each of these histograms, right word probability mass is going to correspond to more well-known concepts. In other words, more concepts that score high on our conceptual possession feature, whereas left word mass will correspond to fewer known concepts. The four models that are highlighted here are trained primarily on English data, and we find that for models trained on English data, additional languages that use the Latin alphabet, in our test suite this is Spanish, German, and Indonesian, all perform considerably better than the non-Latin alphabet languages, Chinese, Japanese, and Hebrew. Similarly, we find that the CogView 2 model, which is only trained on Chinese data, does poorly on all the other languages, although slightly better on Japanese, because we hypothesize that some words have exact character matches to their corresponding equivalents in Chinese. Alt Diffusion is the only model that received multilingual training, and correspondingly, it performs the most consistently across all languages. However, it's interesting to note that this multilingual performance comes at a cost. After all, this is a fork of one of the prior Stable Diffusion models, and it's notably worse on English than the other examples. Future research could probably fruitfully find a more efficient way to improve the multilingual performance without degrading the monolingual initial training language performance. Additionally, we can look at cross-correlations of languages, and what these four plots show, going from left to right, they are German and Spanish, Indonesian and Spanish, Japanese and Spanish, and Japanese and Chinese. We find that script sharing is relatively predictive of performance on a given concept, although there are noteworthy outliers in many cases. So, for example, there are going to be some concepts that do very well in German but very poorly in Spanish, and similarly for all the other language pairs. So there's lots of exceptions. And we can also use these features to zoom in much closer and look at specific concepts and find failures and successes. So what this figure is showing is that we can look at concepts that score high on our conceptual coverage metric, and we find that indeed they look consistent and they look correct. And similarly, we can look at concepts that are low ranking, such as Prince in English, ticket in Chinese, and eye in Hebrew, and we find that the generated images indeed look very incorrect. However, most excitingly, we can use these simple features of conceptual possession as a proxy for the more complex creativity that really impresses lay users. For example, if we have the creative prompt of a bird using a keyboard in the snow, does the individual concept level possession of bird, keyboard, and snow predict success on generating these images? We find that this is partially true, or rather the converse is true. If a model does not possess a concept, given some arbitrary threshold for possession on our features, we find that it will definitely fail on the creative prompt. But the converse isn't always true. We think this is a direction for future work. We find similar results for the aforementioned "a dog made a fire standing on the moon" prompt. If the model doesn't know what fire and moon are, but does know what dog is, odds are, given that prompt, it'll just generate out-of-context images of a dog. This is a good direction for future work. Thank you for checking out my talk. Please Find the paper at the QR code and hyperlink above. This is only our first release of this benchmark, and we hope to expand it to many more languages and concepts. And check out our full interactive demo at the link above.